Hi, in this video we're going to do lesson 5.5 and we're going to do some homework problems from here. The first one is number 12 and it has an exponent on both sides that contains the variable x. So we're going to take the log of both sides of the equation and log of 5 to the x power. We're going to use this opportunity. The properties of log says we can pull the exponent out to the front. We're going to do that on both sides. And since x plus 3 has a plus sign, we have to put it in parentheses. So x plus 3 times the log of 2 is equal to x times the log of 5. Alright, the right side is done. There's nothing really to separate, but you got parentheses over here, and we're going to take this log of 2 and we're going to distribute it into x plus 3. So we're going to be left with this x times the log of 2 plus 3 times the log of 2 is equal to x times the log of 5. Now we're going to take the x's and put them on one side. These two terms have an x. That's what I'm pointing at, and this one I'm pointing at. This term in the middle does not. This term does not have an x, and therefore we're going to leave him right where he's at. He's the only one that doesn't have an x. And we're going to leave this term over here right where he's at. But I'm going to bring this term over, and what that's going to do is make him a negative, because he's positive on the left, he's going to be negative on the right. So minus x log 2. Alright, we got to get these x's together. To do that, we're going to do a little factoring. We're going to factor out the greatest common factor, which happens to be x. So 3 log 2 is equal to x times, well, you're left with a log of 5 when you factor out the x. And you're left with log of 2 when you factor out the x. Close parentheses. We're going to get this x all by itself by dividing this off, okay? And we're going to divide this side by what's in the parentheses here. So I'm going to kind of flip this around a little bit, just to, I'm getting down to the final answer here. To find x, you would have to take 3 log of 2 and you would have to divide it by what's in the parentheses here, which is the log of 5, minus a log of 2. Now all of that, this right here technically is your exact answer. It's asking you for the exact answer in one of your parts of the problem. And then you also have the approximation part. And number 12, when you put it in the calculator, it turns out to be 2.269. And this is your approximation to the thousandths place. And that concludes problem number 12. Now I'm going to move it on. The next problem we have is number 18. Number 18 has x's up in the exponent on both sides again, except for this time we have an e in the problem. And what that's trying to hint at, instead of taking the log of both sides, we're going to take the natural log of both sides, because there's some properties we can use to kind of shorten this problem up. So the natural log of e to the 0.5x equals, and whatever you do to one side, you got to do the other. So the natural log of 3 to the 1 minus 2x. Now, I'm going to change colors here and let you know that the natural log automatically has a base of e. When you see the base of the log match the base of the argument, the only answer. Alright, let me say that one more time. Whenever you have the base of the log match the base of the argument, according to the properties, the only answer left is 0.5x. Everything else kind of cancels according to the property. On the right side, that's not true. You can put an e here and it doesn't match the 3. So we're going to do the same thing we did before. We're going to pull the exponent out to the front. We have to use parentheses. So 1 minus 2x, close the parentheses. and that would be times the natural log of 3. I'm going to take the natural log of 3 and distribute it, so I'll put those arrows on there again to show you what I'm doing. I'm going to multiply the 1, and I'm going to multiply the 2x. So we have 0.5x is equal to natural log of 3 minus 2x times the natural log of 3. All right, so we're going to do the same thing we did last problem, where we're going to put the x's on the same side. So since this has an x and this has an x, I'm going to go ahead and bring this one over here, okay? Now, I'll go ahead and start with the 0.5x here. And then when I bring this term over, it's minus over here, so it's going to be plus over on this side. So plus 2x times the natural log of 3 is equal to the natural log of 3, because this guy is left over there. Okay, we're going to factor out the x again. So pull the x out, and we're left with 0.5 plus 2 times the natural log of 3, close the parenthesis, equals the natural log of 3. We're going to get x by itself, which means we're going to divide off everything that's in the parenthesis and put it underneath this side. So the final answer, the exact answer for x, turns out to be the natural log of 3 divided by, and then we're going to put this in the denominator, 0.5 plus 2 natural log of 3. Now this is considered to be your exact answer. And then for number 18, when you put it in the calculator, you end up getting 0.407. And that would be your approximation to the nearest thousandths. And that completes problem number 18. Now we're going to move it on to number 19. Or I'm sorry, number 24. On number 24, you have to notice that this is the base. The base is 1.2. It's not the 5. The base is holding up the exponent. It's 1.2. Well, we're going to have to get the base and the exponent by itself in order to solve this problem. So treating this like a kind of a normal equation, the first thing you do is move the plus 1 over, and by subtracting 1 from both sides, and that would leave you with 5 times 1.2 all raised to the 3x minus 2, and that's equal to 6. And then we take this, I'm going to change colors here, we take this and we would divide off the 5, because the 5 is not part of the base. And then whatever you do to one side, you got to do to the other. So we got 1.2 raised up to the 3x minus 2 equals 6/5. Now, at this point, there's a couple ways you can solve this problem. I'm just going to go ahead and take the log of both sides. So that's what the theme we've been kind of working on here. So the log of 1.2 raised up to the 3x minus 2 power is equal to the log of 6/5. We're going to pull the 3x minus 2 out to the front. I'm going to move this down just a little bit. We're going to go ahead and write parenthesis 3x minus 2 and write the log of 1.2 is equal to the log of 6/5. I'm going to change colors here, do what we did before, which is distribute the log of 1.2. So we got 3x is going to multiply the log of 1.2 minus 2 log of 1.2 is equal to log of 6/5. All right, we're going to go ahead and move this term to the other side because it doesn't have an x. This is the only one that has an x. So we'll leave this guy over here, 3x log of 1.2 equals log of 6/5 plus, because this guy was minus over here, is going to be plus over here, 2 log of 1.2. And we're going to go ahead and divide off everything that's not an x here. So let me go ahead and change colors here so you can see this. I'm going to divide off the 3, the log of 1.2, and whatever you do to one side, you're going to do to the other, which is 3 log 1.2. This right here is your exact answer to the problem, because x is by itself. Once you cancel these guys out, x is going to be all by itself. Or when you put all of this into the calculator for number 24, you end up getting an answer of 1. And that completes problem number 24. So now I'm going to move it on to problem number 32. Alright, so what we're going to do in this particular problem, since there's a log on one side, in particular it's a natural log, and there is no natural log on the other side, we're just going to use the changing from logarithmic form to exponential form to solve this problem. For instance, a natural log has a base of e. Well, that means in exponential form, that's a nice big e for its base. The exponent is always by itself on the other side of the equal sign, which is 5. And it's equal to the argument, which in this case is 2x. To get x by itself, it's a pretty simple move here. All we got to do is divide by 2. And x turns out to be equal to e to the 5th power divided by 2. And that problem is complete. Nothing else to do on number 32. We have one more problem I have for you, number 42. Number 42 also has the sum of 2 logs, and they both have a base of 10. But there is no log on this side, so we're going to be using that change of form from logarithmic to exponential. But before we do that, we have to put our 2 logs together. Our properties say that to put these 2 logs together.
We've just got a couple of announcements.
Alright, so to put these 2 logs together, to have a plus sign between them, we're going to use the property that says you're allowed to multiply the arguments together. So we're going to take this x and we're going to multiply it by 3x minus 13. And it's still equal to 1. And I'm going to go ahead and change colors here, and there is a base of 10 here because you don't see it under the log. So that means the base in exponential form is 10. The exponent is by itself on the other side of the equal sign, which is 1. And the argument is x times 3x minus 13. To solve this equation, 10 to the 1st power is 10. Distribute the x, that's 3x squared minus 13x. And if we set it equal to 0, that means we're going to move this positive 10 over here and put it as negative 10 at the end. 3x squared minus 13x minus 10. This looks like it could be factorable. Okay, it looks like it could be factorable. Let's see. Let's try a few combinations here. But if it doesn't come up right away, we can use the quadratic formula to solve this problem. The signs, to make a negative 10, would have to be a positive times a negative. To make 3x squared, you'd have to have a 3x and an x. There's no other combination besides 3x and x. To make 10, you'd have to have either 10 and 1 or 5 and 2. Now you would think 10 and 1 might be it, but you're dealing with a negative and a positive, which is not going to add to make negative 13. So I bet it has to have the 5 here, if it's going to work, along with the 2 here. So the outside is negative 15x, and the inside is positive 2. And negative 15 and positive 2 makes negative 13. So that one does work. I'm going to go ahead and set both factors equal to 0. Let me start that one more time. I'm going to take the factor of 3x plus 2 and I'm going to set it equal to 0, and I'm going to write the OR statement, and the other factor is x minus 5, and set it equal to 0 according to the zero product property. And this one over here, 3x turns out to be negative 2, and x turns out to be negative 2/3. On the other problem, x turns out to be 5. Now, as far as the 5 goes, since we're starting with a log problem here, you can take the log of 5. Remember, you can't take the log of negative numbers. You can take the log of 5, and 3 times 5 is 15, and 15 minus 13 is 2. So you can take the log of 2. That's a legal thing to do. But this negative 2/3, you can't take the log of negative 2/3. You know, it doesn't work. You know, it's not in the domain of the logarithm. So this particular one, I'm going to change colors here. This is called an extraneous solution. It does not work, and we don't want to say it is one of our answers. So the only answer we have to this problem turns out to be x equals 5. And that completes this homework video for lesson 5.5.